So now I'm going to show you a demonstration which I find one of the most mind-boggling demonstrations that I have ever seen. We do have a circular track. You have it right in front of you. That is a circle, although you may not think it is, but it is. And that circle has a radius which, according to the manufacturer, is 115 meters with an uncertainty of about, I think it's about 5 meters. It is extremely difficult to measure, and even during transport you think it could change. Let me try to clean this a little better. And so the radius of this, the radius of curvature of our arc, which is also an air track, equals 115 plus or minus 5 meters. So we can calculate now what the period of oscillations is. The whole track is 5 meters long. So half the track is about 2.5 meters. So the angle theta maximum is approximately 2.5 meters, which is half the length of the track, divided by 115, and that is an extremely small angle. That is about 1.2 degrees. Of course, this is in radians and this is in degrees. So the angle is very small, so we should be able to make a perfect prediction about the period. And I'm going to do that. I take 2 pi times the square root of r over g, and r is 115. 115, I divide it by g. I take the square root, I multiply by 2, I multiply by pi, and I get 21.5 t, and this is a prediction, equals 21.5. The uncertainty in r is about 4.3%. Since we have the square root of r, that becomes 2.2%. So if I multiply that by 0.022, I get an uncertainty of about 0.47. Let's call this 0.5 seconds. So this is a hard prediction what the period of an oscillation should be. 21.5 plus or minus a half second. Now I'm going to observe it, and we're going to see how this compares. I don't want to oscillate it 10 times. That will take 3, 4, 5 minutes. That's too long. It is not really necessary because my reaction time is 0.1 second. So even if I did only one oscillation, that would be enough to see whether it is coincident with that, consistent with that number. However, it is such a beautiful experiment. It's so much fun to see that object go back and forth in 21 seconds that I will go, for your pleasure and for my own pleasure, I will go 3 oscillations. Not that it is necessary, but I will do it. 3t is going to be something plus or minus, and this is my reaction time, which is 0.1 second. And then we can all divide that by 3, and then, of course, the error will go down by a factor of 3, and we will see whether this number agrees with this one.